Namaste and a very good morning to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's video, I'll be talking about how to build a linear regression model using SPSS. Even before I proceed to demonstrate how to build a linear regression model in SPSS, may I request you to subscribe to my channel, also like and share my videos. Let me begin by introducing to you the dataset that I'll be using for today's demonstration. I'll be using the dataset which is called as Boston housing data. This data is available in Kaggle. This data is popularly used for linear regression model. What is the Boston housing dataset all about? The Boston housing dataset is a collection of data about houses in the Boston area. It was originally gathered to study the relationship between house prices and various factors. Think of it as a way to understand what affects the cost of buying a house in a particular neighborhood. This data includes information on 506 houses. For each house, it has 14 different features or columns. As you can see here, the first feature that we have is the crime rate. Then we have other important variables like presence of Charles River, which is a dummy variable. Next, you have a column which is called as NOx or nitric oxide. After this, we have another column which is called as the average number of rooms. I will be using all of these variables as the independent variables. As I scroll to the extreme right side, you can see there are important variables like pupil to teacher ratio. You have lower status of population. The last variable that you see is MEDV or the median value of housing price. This variable will be used as the dependent variable. What is the sample size in this data? Let me go to the last record. You can see here the data is approximately 500. The data has approximately 500 rows. With this background, let's now proceed to SPSS. As you can see here, this is a blank screen of SPSS. To carry out any analysis, first of all, you will have to load the dataset. To load the dataset, let me go to the File menu. Let's now proceed to Recently Used Data. SPSS displays 10 recently used files. I will be choosing the very first file, which is called as the Boston housing file. The moment I click on Boston housing file, you can see SPSS loads the file. Once the file is loaded, we are all set to carry out analysis. The very first step for me to carry out regression is to create a correlation matrix. Why is this important? By looking at a correlation matrix, we can tell which are those independent variables which have a strong relationship with the dependent variable. Secondly, we can also tell which among these independent variables are related with each other. Let's first go to the Analyze menu bar. I'll now proceed to correlate. Here, the very first option is bivariate. I'll be using the bivariate option to build the correlation matrix. As you can see here, this is the bivariate correlations window. Let me scroll down. You can select MEDV or the housing price. We can also select some of the other variables like lower status of population, the average number of rooms, the level of pollution, and last but not the least, I'll be choosing crime rate. These are the 5 variables that I'll be using to create the correlation matrix. Make sure that you have selected Pearson under the correlation coefficients option. With these selections, you can go ahead and hit the OK button. As you can see, we are in the output window. This is the correlation matrix. In the column, you can see the names of the 5 variables that I had entered. In the rows, again, you can see the different variable names. There are 3 important observations. The first row here is the Pearson correlation option. Then we have the p-value or the significance value for a two-tailed test, followed by the sample size. When you look at the first number here, it says 1, which is expected because the correlation of housing price with itself will be 1. When you look at the correlation of housing price with LSTAT, we see a negative value. The correlation value is minus 0.738, which is a strong negative correlation. Further, the p-value is 0.000, indicating that this result is statistically significant. What does the negative value indicate? The negative value simply says that as the percentage of lower status of population increases, the median value of housing price comes down. In other words, there's an inverse relationship between these two variables. Further, you can see that there is a positive relationship between the average room size and, my apologies, there is a positive relationship between the average number of rooms and the housing price. When you look at pollution level, there is a negative correlation. However, this correlation is very low. Last but not the least, when you look at the correlation with crime rate, you're again seeing a weak negative correlation. How do you summarize the results of the correlation table? Out of the 5 variables that I had taken, we can clearly see that lower status of population has a strong negative correlation with the dependent variable. Pollution level again has a weak negative relationship, and then crime rate has a weak negative relationship. Number 2, the average number of rooms in the house has a positive relationship. Further, when you look at the significance value, you can see SPSS reports a significance level of 0.000. Since 0.000 is less than 0.05, we can go ahead and say that there is a significant relationship of the dependent variable with each of the independent variables. With this, we have finished the exploratory data analysis. As the next step, what I will be doing is I will be showing you how to build a simple linear regression model. To build a simple linear regression model, you can click on the Analyze menu. We can proceed to the regression option. Under the regression section, the second option here is linear. We have to select the linear option to build a linear regression model. Let me go ahead and select this. You can see here there's a window for linear regression which appears. In the left-hand side, all the variables that were present in the data set is displayed. And the right-hand side, you can see the dependent section and the independent section. There are 2 important points that we need to keep in mind when we talk about linear regression. First, linear regression is a supervised machine learning technique, which means we need to specify a dependent variable. Next, a linear regression is of 2 types. The first type is what is called as simple linear regression, and the second type is what is called as multiple linear regression. In the case of simple linear regression, we use only one independent variable. However, in the case of multiple linear regression, we specify more than one independent variable. I will select housing price as the dependent variable. And when it comes to the independent list, I can choose any of these variables. In the background, you can see LSTAT had the strongest negative relationship. So let me go ahead and select LSTAT as the independent variable. Please observe the method of entry here is what is called as enter method. With this selection, we are ready to build a simple linear regression model. Let me go ahead and hit the OK button. As you can see here, SPSS shows you the output of the regression model. There are three tables here. The first table is variables entered or removed. SPSS describes the name of the dependent variable as medv. It also displays that all the requested variables were entered. Let's move on to the second table, which is called as the model summary table. SPSS prints four important options here. The first is capital R, which stands for multiple correlation coefficient, and the value here is 0.738. The second option that SPSS shows is R square. What is R square? R square stands for coefficient of determination. It tells me the goodness of fit. How good is our linear regression model? R square lies between 0 and 1. If the value of R square is close to 1, we can say that the model fits the data well. On the other hand, if the R squared value is close to 0, it means that the model does not fit the data well. Typically, R squared value of above 0.7 is considered as a good model. As you can clearly see here, the R squared value that I am getting is 0.54, which implies that 54% of the variation in the dependent variable is explained by the independent variable. That is, 54% of the housing price in Boston is explained by the independent variable, namely lower status of population. We also see another important statistic, which is called as adjusted R squared, followed by the standard error of the estimate. What you can do is you can double click on the adjusted R square. Right click on this and choose what's this option. SPSS helps you interpret each and every statistic that is there in the output section. So let me go ahead and select what is this. You can see here SPSS says the sample R squared tends to optimistically estimate how well the model fits the population. The model usually does not fit the population as well as it fits the sample from which it is derived. This is where adjusted R square comes to our rescue. Adjusted R squared attempts to correct R squared to more closely reflect the goodness of fit of the model in the population. This is about adjusted R square. Let's come to the final table, which is the model coefficients table. SPSS displays the unstandardized coefficients. Here you can see the constant term or the intercept term value. Further, you can also see the beta coefficient for LSTAT is displayed as negative 0.950. You can see the standardized coefficients, and then you can see the T statistic value. I'm really interested in the significance value. For LSTAT, the significance level value is 0.000, indicating that LSTAT value or lower status of population is a significant predictor. As you can see here, I've got a very low R squared value. There are different ways in which you can boost the R squared value. One is to add additional variables. The second one is to transform the dependent variable. Let me go ahead and show you how we can include additional independent variables so that we can mop up our R squared value. Let's go to the Analyze menu, go back to Regression. The second option here is Linear. In the independent list, you can see there is only LSTAT. I will select all the variables here. You can see here, now, since I've selected 13 variables under the independent section, this would be an example of multiple linear regression. Let's go ahead and click on the OK button. Once I click on the OK button, you can see SPSS calculates the regression output. You can see here, this is the list of the independent variables that I have taken. The new R value is 0.861. The R squared value that I'm getting is 0.741. Please compare it with the earlier model summary output. The earlier R squared was only 54%. However, the current R squared value is 74%, which means that 74% of the variation in the dependent variable is explained by the set of independent variables that I have taken. SPSS displays the names of all the important, in fact, it displays all the independent variables. You can see here the ANOVA table, and along the column, you can see sum of squares, degrees of freedom, mean square, F statistic, and the p-value. In the row, you can see there is a breakdown of the regression sum of squares and the residual sum of squares. And finally, SPSS displays the total sum of squares. How do you look at these numbers? When you look at the regression sum of squares, it is approximately 31,637. When you divide this number by the degrees of freedom, you will be getting the mean squared value of 2,433. When you look at the residual sum of square, the value is 11,078. When you divide the residual sum of square by its respective degrees of freedom of 492, you'll be getting the value as 22.51. When you take the ratio of regression sum of square and the residual sum of square, you will be generating the F statistic, and the significance value is reported for the F statistic. Remember, a low p-value is a good sign. The p-value that I've obtained here is 0.000, which is less than 0.05. And therefore, I can go ahead and conclude that the R squared here is significant. With this, I'll come to the coefficient section. You can see here, SPSS reports the unstandardized coefficients for each and every independent variable. Let me draw your attention to nitric oxide. The unstandardized coefficient here is minus 17.7. What does this indicate? This simply means that if the pollution level goes up by 1 unit, the housing price comes down by $17,000. I repeat, if the nitric oxide concentration goes up by 1 unit, the housing price comes down by 17,000 units. Let's look at the number of rooms. There's a positive quotient of 3.8. Let me round this off to 4. What does this indicate? This simply says that if the average number of rooms go up by 1 unit, the housing price would go up by $4,000. It's also very interesting to note that there is a negative relationship between crime rate and housing price. I'd like to draw your attention to the last column, namely the significance column. As you can see here, SPSS reports the significance column for each and every variable. It's very interesting that some of these values are insignificant. For example, the column indus. You can see here, this is the variable indus, and the p-value that we are getting is 0.738, which is clearly bigger than 0.05, and hence it implies that the variable indus is an insignificant predictor. I can say the same thing about age because the p-value is bigger than 0.05. The other variables have a p-value which is very low, and hence we can go ahead and conclude that the other variables are important. At this stage, I'd like to draw your attention to the third important thing in this video, which is variable selection. How do we filter out useless variables and retain only good variables? When I say good variables, I'm referring to important variables, important from the perspective of p-value. To select only the useful variables, what you can do is click on the Analyze menu, go to the Regression section. You're already familiar with the options in regression, so let me go straight to the Linear Regression option. As you can see here, I'm not going to make any change as far as the dependent and the independent variables section is concerned. Let me draw your attention to the method option. The default method is enter, which simply means that SPSS will be generating the coefficient as well as the p-value for each and every variable that you have entered. If you have entered 40 variables in the independent list, SPSS will produce the significance value for each of these 40 variables. Let me click on the drop-down menu here. You can see here there are different variable selection methods. You see what is called as the stepwise method. Then we see the removal method. We see the backward elimination method. And finally, we see what is called as the forward selection method. Let me go ahead and choose the forward selection method. For those of you who are new to statistics, you might want to explore what is the forward selection method. Forward selection method is a stepwise variable selection procedure in which the variables are sequentially entered into the model. I repeat, this is a stepwise variable selection procedure in which the variables are sequentially entered into the model. The first variable considered for entry into the equation is the one with the largest positive or negative correlation with the dependent variable. This variable is entered into the equation only if it satisfies the criteria for entry. If the first variable is entered, the independent variable not in the equation that has the largest partial correlation is considered next. The procedure stops when there are no variables that meet the entry criteria. So the summary of what I'm trying to tell you is that forward selection method is a variable selection method. It removes unimportant variables and builds the model with only important variables. Let me go ahead and hit the OK button. You can see here, this is the output of the forward selection method. SPSS has built multiple models. The first model is built using LSTAT. The second model is built using rooms. You can see here, the method of selection is mentioned. This procedure goes on sequentially till such time as the final model is built. As you can see here, SPSS has built the final model in 11 steps. Let's now look at the model summary table. The first model has a R-squared of 54%. This improves to 63% in the second step, and further the R-squared improves to 67%. In the 11th step, the R-square climbs up to 74%. You can see here, in the last step, this is the final list of variables that SPSS has selected. It automatically discards unimportant variables. Let's now proceed to look at the ANOVA table. As you can see here, the significance value is less than 0.05 in each of the steps. Let's now take a look at the coefficients table. You can see here, you are getting a big table because SPSS has built the model in 11 steps. You can see here, these are the variables that SPSS has used to build the final model. Let me scroll down again. You can take a look at the p-value here. The p-value is less than 0.05 for each and every variable. Thus, we can build a parsimonious model, implying that we don't have to build a model with insignificant predictors. With this, I have come to the end of today's video. In today's video, we have seen how to generate a correlation matrix. We have seen what is the difference between a simple linear regression model and a multiple linear regression model. Finally, we have also seen how you can select the best combination of variables using the forward selection method. I hope you have liked this video. I request you to subscribe to my channel, also like and share my videos. Thank you very much for watching this video. Have a great day ahead.